This lesson we're looking at factorizing monic quadratic trinomials. Now there's a couple of new words here, starting with monic. So monic means that we have a coefficient of x squared equal to 1, meaning the number that's in front of the term that has the x squared has to be 1. So we don't want anything there in front of the x squared except for 1. So that's what monic means. Trinomials are expressions or equations that has 3 terms. So you can see there's a bunch of trinomials here. They all have 3 terms. And these are all monic. You can see they have nothing in front of the x squared. However, this one isn't monic, but we'll see how we can manipulate this and turn it into monic a little bit later. Now, there is one particular skill or a method that you need to use when it comes to factorizing monic trinomials, and this is the method. So for example, if let's say we have this expression here, x squared plus 8x plus 15. There are 3 steps to follow to do this. The first step is to think of factors of the constant term. So constant term is the one there that has no letters. So think about some possible combinations of factors here. So you can see there's 1 and 15 and the 3 and 5. And then your second step would be we want to pick a combination. So we have combinations 1 and 2 here. We want to pick one that when we add them up, so if we add up 1 and 15, we get 16. And if we add up 3 and 5, we get 8. And we want them to add up so it matches the number that's in front of the middle term there. So in this case, you can see we will have to pick 3 and 5. And once we pick them, we can write 3 and 5 here underneath the 15. And underneath the x squared, we write the factors of x squared, which are x and x. And your final step is to take this x and 3 together and put it into a bracket. Take this x and this 5 and put it into another bracket. So we factorize this as these 2 factors here. All right, let's practice this a little bit more. Over here, we've already done A. A is the one we just did. So starting with B, we know x has x and x as factors. Just do this. Now we got to think about some combinations of factors for 6. We've got 1 and 6. And then we've also got, what do we got? 2 and 3. Now, we somehow have to add these 2 up, and then they have to equal to -5. Now, the first one equals to 5, positive. Second one equals to 7 when we add them up. So they're both no good. However, that's all we have. We don't have any other combinations. So now we need to be a little bit clever about this and think, wait a minute. If we have negative numbers, they are also factors of +6, because -2 times -3 will give you +6. -1 times -6 will also give you +6. So these are also factors of 6 when they're all negative, because they all give you +6. Now, if we take these 2 numbers, -2 and -3, and we add them up, so -2 plus -3, we're going to get -5. So this is actually really good. So we are going to take these 2 numbers, -2 and -3. So they meet the criteria where these 2 multiplied together will give you 6, +6. And when they're added up together, it's going to give us -5. So now our final step is to just putting them together, x minus 2 and x minus 3, and those are the factorized form of this. And we'll do C as well. C is non-monic, so it has a 2 in front of x squared, so we can't use the method that we used. It only works for when they're monic. However, what we can do is to realize, well, all of these 3 terms have 2 in common as their factors. So we take the 2 out, then we are left with a new trinomial where it is monic. So now we can do what we've just done. So think about some factors of negative 14. So it could be 2 and 7 gives you 14, but one of them has to be negative. This can be negative because when you multiply these 2 together, it's going to give you negative 14. Or the 7 can be negative as well, because when you multiply 2 and negative 7, it's going to give you negative 14 as well. Now, we want 7 to be negative in this case, because when we add these 2 up, we want it to equal to negative 5. So if we have negative 2 plus 7, that's going to give us positive 5. But if we have negative 7 plus 2, that's going to give us negative 5. So we want to pick this combination where the 7 is negative. And then we write the x's here. Alright, so you just need to keep the 2 in front. That's still there. But inside this bracket, we've got x plus 2 and x minus 7. That's the factorized form. Alright, this last one here, we've got 16 and 8 to deal with, but 8 is negative. So 4 and 4 gives you 16. But we want them to add up to negative 8. So if we make them both negative, they still give you positive 16 when you multiply them together. But when you add them up now, it's going to give you negative 8. So it's good for us. So we've got x minus 4, and then another x minus 4. And that's our factorized form. However, they're both the same terms multiplied together. So we can write it as x minus 4 all squared. Our final step is to use what we've just learned to simplify these crazy looking fractions. So over here, up top, you can see there's a monic trinomial there. So we'll try to use what we've just done over here to see if we can factorize this. So if we do 1 and 6, and then we make one of them negative, let's make the... actually 1 and 6 is no good. Let's do 2 and 3. So 2 and 3 gives you 6, but it's a negative 6. So we want to make one of them negative. And we want to make 3 negative because we want them to add up to negative 1. Then we have x plus 2, x minus 3 on top. And down the bottom we have x plus 2. And as you can see, we have the x plus 2, they're both in common, meaning that we can cancel them out because they're in a fraction. And we're left with just x minus 3. And we can even do the same with this crazy one here. As you can see, there's a couple of trinomials here, these two. So let's factorize them. So factorizing this one first, we have x and x here, and we have, let's think what gives you 15. We can do 5 and 3, and we have to make one of them negative because it's negative, and we also want them to add up to negative 2. So we want to make the 5 negative, then when we add negative 5 and 3 together, it gives you negative 2. So this factorized is going to be, and we've done that, so put this away and we'll do this guy over here. We have 1 and 5 as factors of 5, but again it's negative 5, and so one of them has to be negative. And we want to make the 5 negative because when we add them up we want it to be negative 4. Meaning that this can be now factorized as this. Alright, now we've done all the hard work. Let's rewrite this fraction. So we've got x squared minus 9 on top. On the bottom we have x minus 5, x plus 3. And we're timesing this with, over here we have x plus 1, x minus 5, and down the bottom we have 2x minus 6. Now, we were hoping to cancel out some from the top and some from the bottom, but so far we have nothing in common from top to bottom. However, we can factorize this further, like this one over here. It looks a lot like, we can rewrite this as x3 squared. Let's rewrite it like that. And then this one over here, this stays the same, but on the bottom, let's factorize so it has 2 out front and we have x minus 3. And over here we have difference of perfect squares, so let's use dots to factorize this. So x plus 3, x minus 3 over x minus 5, and then x plus 3 times, and we'll just rewrite this whole thing, hoping that we can cancel some stuff out because there's a lot going on. And we can see these two are in common, so let's cancel them out. And it seems like that's the only thing that's in common so far. So we're just going to do that, leave the rest as is. And then now we'll perform this operation in the middle, which is times. So when we times two fractions together, all we're doing is multiplying the top together and then multiplying the bottom together. So if we do that, on the top we have a lot going on. We have this timesing with this and this. So all of this we can write together. On the bottom we have this timesing with 2. So let's just write the 2 at the front, and timesing with this as well. Alright, now we have a few more things in common. So you can see these are in common, but these are also in common. So we can cancel all of them out. So on the top we only have x plus 1 left. On the bottom we have just the 2 left.